Hello everyone, welcome to Smart Interviews. I hope you're all doing great. Let us solve a problem from the lead code. Here is the problem. I strongly recommend you to pause the video here, go through the problem link in the description, and come up with an approach of your own. Now, let us try to understand the problem statement. Given the root node of a binary search tree, you're supposed to find the nodes which are occurring maximum number of times. So it is called the mode of the tree. And we can have multiple such modes. Now, let us try to take an example first and try to analyze it with the help of an array. So here in the given array, we are having values 3, 4, 1, 1, 3, 2, 2, 3, 2. Now, what would be the answer for this? Here we are having 3 occurring thrice, and along with that 2 as well is occurring thrice. So both 3 and 2 are our answers. Now, if you're trying to find the mode in the array, what would be the simpler way in order to find the mode in the array? Right. It is easy for us to sort the array and then come up with the mode. Let us try to do the same. What would be the sorted array like? The sorted array will be having 1, 1, followed by 2, 2, 2, and then 3, 3, 3, and then 4. Right? Now let us try to compute the mode in the array. So initially, let us take 3 variables. The current value, indicating which value we are at, and current count, indicating the number of repetitions of the current value, and the third one, in order to find the max, we need to have the max count. So initially, all the variables will be initialized to 0. Now, let us start iterating on the array. Let us start with 1. So the first element 1 is the first occurrence. So we are supposed to update the current value to 1. And since we are updating the current value, it indicates that this is the first occurrence of the value. So reset your count to 1. And if you can compare the current count with the max count, we find that current count is greater than the max count. So we are supposed to update the max count as well. So update the max count. Now, as we can understand, till this point, what is the most occurring element? Right, 1 is the most occurring element. So let us take an answer variable. So initially, we'll be having 1. Why? Till now, it is the most occurring element. Now, let us try to move forward to the next element, that is 1 again. Now, as we can see, the current value here is 1, and the element that we are at present as well is 1, indicating that we are supposed to increment the current count. So now the current count would be 2. And as we can see, the current count is greater than the max count. So we are supposed to update the max count. Update the max count. And since max count is updated, remove the existing elements from the answer and then add the current value. Now remove 1, and since the current value as well is 1, again add back 1. Now moving forward to the next element, that is 2 in the array. And as we can see, the current value is 1 and the current element in the array is 2. There is a change in the values. Now we can update the current value. Now before moving to updating the current value, is there a possibility that can we have 1 again in the future? Of course not. Why? Because the array that we are having is sorted. Now let us move ahead and update the value to 2. Right? And since we updated the current value, we're as well supposed to reset the count back to 1. So update the current count back to 1. Now, as you can see, the current count, it is less than the max count. So just move ahead to the next element in the array. Here, the next element as well is 2. So we are supposed to increment the current count. Why? Because it is same as the current value. So increment the current count to 2. And now, when we compare the current count with the max count, both of them are same, indicating that the current mode that we are having, it is occurring twice, and the value that we are having current as well is occurring twice. So both of them will be the answers. So include 2 into the answer. Now move ahead, and the next value as well is 2, and the current value as well is 2. Since both the values are same, increment the count to 3. And now as we can compare the current count with the max count, current count is greater than the max count, so we can update the max count. Along with updating the max count to 3, we're as well supposed to clear the existing answer and then again add the current value into the answer, that is 2. And now once we are done with this, move ahead to the next value, that is 3. Now for 3, the current value here is 2 and the element that we are having in the array is 3. So update the current value to 3, and since we updated it, reset it back to 1. Now the max count as of now is 3 and the current count is 1. So there is no need to update the max count. Move ahead to the next element, that is 3 as well. So update the current count. And since again it is less than the max count, move ahead to the next value. And here the next value as well is 3. And it is same as the current value. So update the current count to 3. And current count is same as the max count. So add the value into the answer. And the next value that we are having here is 4. And 4 is not same as the current value. So update the current value to 4. Since we updated, as we discussed, reset the current count back to 1. And now the current count is less than the max count. So just simply move ahead. And we are done with the array. So ultimately, the answer for this array would be 2 and 3. Now, let us try to understand if we can apply the same thing on the binary search tree. So in order for the binary search tree to have a sorted elements, which traversal will help us to have the elements in the sorted manner? Right. In-order traversal will help us to have the elements in the sorted manner. Now let us try to understand how it is going to exactly work in the tree. So let us reinitialize the variables back to 0. And as discussed, let us try to have an in-order traversal on the binary search tree, starting from the root node, that is 4. And here, since it is an in-order traversal, we are first supposed to move to the left subtree, that is 4 again. And again, further to the left of it, 3. And further to the left of 3, it is 2. Now, update the value of 2. As we can see, the current value is 0 and the value we are having at the root is 2. So update the current value to 2. And the count should be 1. And the max count is less than the current count. So update the max count to 1. And along with this, we are as well supposed to update the answer. The answer is now going to be 2 initially. And now, once we are done with 2, there is no right child of 2. So move back to the parent of 2, that is 3. And since now we are at 3, we can clearly see that the current value is different from the root value. So we need to update the current value to 3. And since we have updated the current value, the current count as well should be updated to 1. And as we can see, the current count is same as the max count. We are supposed to add 3 into the answer. So add 3 to the answer. Now moving ahead. Since we are done with the root, we are supposed to move to the right child of it. And as we see, the right child as well is containing the value as 3, which is same as the current value. So update the current count to 2. And now when you compare the current count to the max count, the max count is smaller compared to the current count. So update the max count to 2. And as we can see, we have updated the max count. So whenever we are updating the max count, we are supposed to remove the existing elements from the answer and then add the current value into the answer. So remove 2 and 3, and now the current value here is 3. So add it back. Now let us move ahead to the next value in the in-order traversal. Since we are done with the right child, we move back to the parent of 3, that is 4. So now you are at 4. You are done with the left subtree. Now we are at 4. As we see, the current value is different from the root value. So update the current value. The current value will now be 4. Since you updated the current value, the current count, it is going to be 1. And as we see, the current count is less than the max count. So just move ahead. Now the next value in the in-order traversal would be the right child of 4. But there is no right child of 4. So move ahead to the parent of 4. And as we see, for the parent of 4, the entire left part is done. For the right subtree, before moving to the right subtree, we are first supposed to process the root node. So the root node is containing the value as 4. Since it is same as the current value, update the count to 2. And now as we see, the max count is same as the current count. So add the current value into the answer. Now it is going to be both 3 and 4. Now since we are done with the root, move ahead to the next value, that is 4. That is the right of the root. And since we are following the in-order traversal, we are first supposed to move to the left subtree of this 4. And since we are not having any elements onto the left subtree, we can directly process the current 4 itself. And as we see, the current value is same as the root value. So update the count. And here the current count, it is going to be 3. And as we see, the current count is greater than the max count. So update the max count as well to 3. And as we discussed earlier, if you are updating the max count, remove the elements from the existing answer and add the current value again. So here we are going to remove both 3 and 4 and then add 4 again. Now moving to the next element, we are moving to the right of it, that is 6. And here, since we are again following the in-order traversal, we are first supposed to move to the left of 6. So move to the left of 6. And here the value is 6. And there is no left child for the existing 6. As we compare the current value with the root value, we see that both are different. So we are supposed to update the current value to 6. And since we are updating the current value, reset the current count back to 1. Now the current count is resetted back to 1. And max count, it is greater than the current count. So just simply move ahead. And here the next value that we are going to have is the parent of 6, that as well is 6. And the root value is same as the current value. So update the current count. And current count is less than the max count. So just simply move ahead. Now when you move to the right of 6, the root value here as well is same as the current value. So update the current count to 3. And as we see, the current count is same as the max count. Add the current value into the answer. So now answer is going to be 4 and 6. And as we see, there is nothing to the right of 6. So we are done with the in-order traversal, and ultimately we have our answer as 4 and 6. Now let us try to code it up. So here we are initially given the find mod function, which is having the parameter as the root node of the tree. Now before moving ahead, what all are the variables that we need? Right. So here we need current value, which is initialized to 0. We need current count, which as well is initialized to 0. And we need max count, which as well is 0. And now, along with this, we need to store our answer. So let us take a vector of type int. Let us call it as modes. Now, in the find mode function, let us try to take the help of another function, and let us name the function as find mode helper. And we are supposed to pass the root of the tree as a parameter for this function. Now, as we discussed, we are supposed to follow the in-order traversal. Now, if you're following the in-order traversal, we are supposed to execute our left subtree first, and then root, and then the right subtree. So, let us write a recursive call, and the find mode helper will be helping us to get the mode from the left subtree, that is root left. And once we are done with that, now we are supposed to process the root. So if the root value that we are having, if it is same as the current value, in that case, what are we supposed to do? Right, we are supposed to increment current count. Else, as in if they are not equal, in that case, update the current value to the root value. So current value will be equals to root value. And along with that, we are supposed to reset the current count back to 1. And once we are done with the comparison of the current value and the current root, what are we supposed to do? Now we are supposed to compare the max count and the current count. So take if the current count, if it is same as max count, in that case, we are supposed to add the existing current value into the modes. So modes dot pushback of current value. Now, if that is not the case, as in else if the current value, if it is greater than max count, here it is current count, in that case we are supposed to clear the existing answer list, that is mode dot clear, and along with this we are supposed to add the current value back again into the modes. So and along with this, we are as well supposed to update the max count. So max count will be equals to current count. Now, once we are done with this, we are supposed to call the same thing on the right side. So call find helper on the right subtree, that is root right. And what else are we missing here? Right, we are supposed to add the base condition for the recursive function. So here, if root is same as null pointer, then we are supposed to return. So what is the return type of this function? Right, we are taking care of the answer from the modes. So here it is just sufficient to have it as a void return type. So the find mod helper will be a of type void. So here just simply return back. Now once we are done with this, we are supposed to call this function helper from the find mode function. So find mode helper of root, and once we are done with this, just simply return modes. Now let us try to run the code. The test cases got submitted successfully. Now let us try to submit the code. Great. Solution got submitted, accepted successfully. Okay guys, see you in the next video. Thank you for watching. Please like, share and subscribe for more such content.